Oh,
Good afternoon to one and all present over here, respected subject teacher and all my beloved friends. It is a great pleasure to be standing here in front of you all to be presenting on the topic real numbers. So the topic real numbers will be presented by me, Shripara Thapa. Me, Kriti Triputa. So without any delay, let me just start with the basic introduction on real numbers. So first, So real numbers, in basic definition, real numbers are basically all those numbers we use in daily life. So numbers including positive numbers, negative numbers, fractions, decimals, and zero. So real numbers, a basic way that you can remember what a real number is, if you can represent a real number, if you can represent a number in a number line, then it can be easily classified as real numbers. So there are a few types of real numbers given in our book. So here are the 5 basic divisions that are given in our book. So the first is natural numbers. Natural numbers are all the numbers that we learn from the basic age of 2 or 3. So all the counting numbers like 1, 2, 3, and so on. All of them are natural number, and and its other name is also counting numbers. The next is whole numbers. Whole numbers are basically set of natural numbers, but zero is included in it as well. Next is integers. So integers, in our book, there is given 3 divisions inside integers as well: positive integer, negative integer, and zero. So all the numbers in front of zero are negative integers, and all the numbers behind zero are the positive integers. And next is rational numbers. Rational numbers are all those numbers that can be expressed in the form of fraction, that is p by q. So some basic examples of rational numbers can be 0.5, which can be written as 1 by 2, and 0.33, which can be written as 1 by 3, um, and minus 5, which can also be written as minus 5 by 1. So these all fall under rational number. Next is irrational numbers. Irrational numbers are basically all those numbers that do not fall under rational numbers. And irrational numbers cannot be expressed in simple fraction forms. So a few examples are root 2 and pi. So their value is their decimals keep on going on, and their decimals never repeat. And a common mistake that can be done in irrational numbers is thinking numbers like root 4 or root 9 also falls under irrational number, which is not true because they are a perfect square root. Only the numbers that are not a perfect square root fall under irrational number. So this is the basic introduction, which may not seem that important, but it is a base to help you understand the given chapter better. Next presentation will be done by Krishna. Thank you,
Shrikana. Now I'm going to talk about laws, general representation of real numbers in real line and interval. So, the first law is trichotomy law. In this law, for any a and b, one and only one of the following is true. Either a equals to b, a is greater than b, or a is smaller than b. Next law is transitive law. This law implies that if a is smaller than b and b is smaller than c, then a is also smaller than c. Next law is additive law. In this law, if a is smaller than b and c is any real number, then a plus c is smaller than b plus c. The last law is multiplicative law. If a is smaller than b and c is greater than 0, then a dot c is smaller than b dot c. And if a is smaller than b and c is also smaller than c, then a dot c is greater than b dot c. Now next topic is representation of real numbers in real line. So every real number is a point on a straight line, and basically every point on a straight line represents a real number. As we know that the real numbers are the collection of rational and irrational numbers, and also real line is composed of rational and irrational numbers. So I'm going to show only the representation of rational numbers in real lines. This is the representation of rational numbers in a real line. Now next topic is interval. For let us suppose a and b be any two real numbers in real line such that a is smaller than b. So all the set of the real numbers in the real line between a and b are called an interval, and a and b are the endpoints of the interval. So according to the involvement of these endpoints, there are following types of intervals. So first one is open interval, closed interval, left closed or right open interval, or left open or right closed interval. So this one is open interval where this one is open interval. It is notated by a small bracket, and this is the graph representation of open interval. Here it implies that it doesn't contain both a and b. This is closed interval. So this interval states that it contains a and b both the endpoints. Or one is left open or right closed interval. This is the graphical representation, and it states that it doesn't contain a, but it contains the point b. Last one is left closed or right open interval. This is the graphical representation, and it contains a, but it does not contain b. So for the remaining topics, I would like to call it creative.
Now I would like to talk about the absolute value of a real number. Absolute value of a number is the distance from 0 to the number line. So absolute value of x can be represented as this.
absolute value is always non-negative. So if a number is positive, then the absolute value of a number is also positive. But if a number is negative, then the absolute value of the number is the positive version of a number. So for example, the absolute value of 5 is also 5, and the absolute value of -5 is also 5 in a number line. In a number line, -5 is 5 units away from the 0, and 5 is also 5 units away from the 0. So -5 and 5 both have the same absolute value. So absolute value can be used in our real life also. It is used in calculating the distance between 2 points. And now the properties of absolute value. So first property says that x is always less than or equal to the absolute value of x, and minus x is also less than or equal to the absolute value of x. In simple word, we can understand that the absolute value of x is always greater than the number itself, whether it is positive or negative. Next property is says that the absolute value of the product of two numbers is always equal than the absolute value of the product of two absolute values. In simple word, we can understand that if we take two numbers and first multiply and then get absolute value, or if we multiply two absolute value of a number, then the product is always same. Same goes here. Instead of multiplication, there is division. Third one is the important one. Third properties is about the triangle law of inequality. From the examination views as well, it is the important one. It says that the absolute value of the sum of two numbers is always less than or equal to the sum of two absolute numbers. For example, so from example also we can see that the absolute value of the sum of two numbers is less than the sum of two absolute numbers. Next property is just the opposite of the third property. Next property says that the absolute value of the difference of two numbers is always greater than or equal to the difference of two absolute numbers. From the same example, so from example also we can see that the difference, absolute value of the difference of two numbers is always greater than the difference of two absolute numbers. in next property we can see that if a number is positive and x absolute value of x is less than the positive number, if and only if minus a is less than x and x is also less than a. But in next condition we can see that if a number is positive but the absolute value is greater than the positive number, if and only if minus x is greater than x and x is less than a. This is the end of the theory part. Now so we have to express this equation in the form of absolute value. Firstly, we have to add constant in all the sides. Previously, I told that the absolute value are always same, but the sign of the value are opposite. So minus 3 plus k equals to minus 4 minus k. On solving, the value of k is minus 1 by 2 and putting the value of k in equation 1. On solving, minus 7 by 2, 2x minus 1 by 2, 7 by 2, it can be written as so this is the end of our presentation. I would like to call my teammate for the ending of this presentation. So if you have any question, you can just ask us. Otherwise, this is the end of our presentation. Thank you.